to applications of differentiation of logarithmic functions. So a reminder from our last video that on our formula sheet, if y equals log base e of f of x, or ln of f of x, the derivative is the function goes on the bottom and f dash of x goes on the top. And we're going to look at gradients, equations of tangents and normals, stationary points, etc. when we apply this. So here's our first one. We're going to find the equation of the tangent to the curve y equals x ln x at the point 1, 0. So equation of the tangent. So reminder, if we're finding a tangent is a straight line, so equation of a straight line is y minus y1 equals mx minus x1. So to get the gradient of the tangent, that's from the differentiation. And of course, we're now using logarithms. We've been given the point, so you've been given the x1, y1, so you don't need to go and find the y because it's actually given to you. So finding the gradient of the tangent, from the previous video we watched, we used the product rule, and the differentiation of x ln x is 1 plus ln x. So if we want to find the gradient of the tangent, when x equals 1, we sub in 1 for the x value into dy dx. And you get 1 plus ln 1, and ln 1 is 0, so the gradient of the tangent is 1. So the equation, using our equation of a line rule, you get y equals x minus 1 once you substitute in. So for our second example, for the function y equals x over ln x, we're going to find the stationary points and determine their nature. So stationary points, when y dash equals to 0, determine their nature, that's from the table of slopes. So differentiate y dash equals 0, and once again from a previous video, we're going to use the quotient rule. So you've got x over ln x. When you differentiate that, you get ln x minus 1 over ln of x squared. So we let that equal to 0. Remember, the denominator cannot equal to 0, so the only solution is what's on the top of the what's on the numerator. So ln x minus 1 equals 0, so ln x equals to 1. That's log base e of x. So since it's base e, x equals e to the 1. So that's our x value. And we're finding stationary point. So a point is an x and a y value. So if x equals e, and I substitute it in, I get e over ln e, and log base e of e is 1, so y equals e. So we have a stationary point at the point e. Table of slopes, so e is 2 points something, so we pick a value either side. So we pick 2 and 3, substitute it in, and so at 2 it's a negative, and at 3 it's a positive. So therefore we get a minimum turning point at the point E. If we were asked to sketch, then we'd get that minimum turning point. The vertical asymptote at x equals 1, as ln 1 would make the denominator 0. And since ln x is a function, the domain is from 0 to 1, union 1 to infinity, because obviously 1 was our asymptote. And check points either side of the asymptote along with larger values of x. That would be our graph, and that's what we're looking at. As you can see, there's our turning point. At x equals 1, our asymptote, so you can see it approaches on the right-hand side, it approaches positive infinity. On the left-hand side, it approaches negative infinity. And because it's a log graph, it can't be negative because you can't take the log of negative values, and you also can't take the log of 0, so you can see it's an open circle at 0. Thank you.